Okay, so now we're on part 3. We're doing expressions of the form a times sine x plus b times cosine x. So we've got 1/2 sine x plus the square root of 3 over cosine x. And we want to put this into a single trigonometric function using the addition formula for sine. So what value on our unit circle can we choose? We're talking pi over something, where we have 1/2 and the square root of 3 over 2. We want those coefficients. We want the cosine and sine part to be that. Well, if we pick the pi over 3, that would give us cosine of 1/2 and sine of the square root of 3 over 2. Well, that would work into our formula using the addition sign formula, where we have, so we're looking at doing, if we set phi equal to pi over 3, then we would have cosine phi is equal to 1/2 and sine phi is equal to the square root of 3 over 2. So then we would have 1/2 sine x plus the square root of 3 over 2 of cosine x is equal to cosine phi sine x plus sine phi cosine x. Well, that will equal the sine, the addition formula of x plus phi. So that would equal the sine of x plus pi over 3. So we chose that 1/2 and the square root of 3 over 2 because it fits what we're trying to do. Because the cosine addition formula, we need the sine addition formula, we need cosine and sine plus sine and cosine. Because these two values were already here, we need the cosine and the sine value. So basically we're doing a substitution. So the cosine of 1/2 equals 1/2, and the sine equals the square root of 3 over 2, and that goes with our pi over 3. It wouldn't work if we picked a different value because we need it to be the ones that have the same values there. Okay? Now, in general, the ax sine x plus bx the a times sine x plus b times cosine of x. We're going to use the form of k times sine of x plus phi. So I'm not going to work the proof of it, but what you need to understand is that the cosine of phi will be equal to a over the square root of a squared plus b squared, and the sine of phi is equal to b over the square root of a squared plus b squared. And the formula would become a times sine x plus b times cosine x would equal the square root of a squared plus b squared times the cosine of phi sine x plus sine of phi cosine x. So this would equal the square root of a squared plus b squared times the sine of x plus phi. Because this is the addition formula of sine, we can pull out our x and our phi. Well, what does this do for us? Well, this gives us the sums of sine and cosine formulas. which is what we are going to use next. This leads us to the sum of cosines, sines, and cosines formula. This will be on page 550 in your book, is where you can find the formulas for that. All right, so we are going to use our sum of sine and cosine, and we are going to do an expression. So I'm going to switch pages here. So we are going to express 3 sine x plus 4 cosine x using that form of k sine x plus v. All right, so to do k, we've got k is equal to the square root of a squared plus b squared. So we got to know what a and b are. Looking at our equation here, or expression, a is going to be equal to 3 and b is equal to 4. So that means k will be equal to 3 squared plus 4 squared, which will be the square root of 9 plus 16, square root of 25, so k will equal to 5. Well, a squared plus b squared was the bottom of our sine and cosine formulas. So we are going to get sine of phi is equal to b over k, and b is 4 and k is 5. And cosine of phi was equal to a over that square root of a squared plus b squared, which is going to be our k, is equal to 3 over 5. So phi will be in quadrant 1, where sine and cosine are both positive. If we want to find the value of phi, phi would be equal to the sine inverse of 4/5, because that's our sine value. And that, if you plug it in your calculator, will get you 53.1 degrees. So we could say that 3 times sine x plus 4 times cosine x will be equal to, putting it in our form here of 5, or k times sine x plus phi, would get us 5 times sine of x plus 53.1 degrees. Okay. The last part we're going to do is we're looking at graphing a trig function. So we're talking about graphing a trig function. So we've got f of x is equal to the negative of sine 2x plus the square root of 3 of cosine of 2x, where we have k of sine is equal to 2x plus phi. So here's our solution. First of all, we need to know what a is and what b is. Well, a is -1 and b is the square root of 3. So k will be equal to a squared plus b squared, which is going to get us the square root of -1 squared plus square root of 3 squared. -1 squared is 1. Square root of 3 squared is 3. So that'll equal the square root of 1 plus 3, which is 4. Square root of 4 is 2. So if we're looking at cosine of phi, would be equal to a over k, which is -1 over 2. And sine of phi is equal to b over k. And b is the square root of 3 over k, which is 2. So what quadrant are we in? Well, we have cosine is negative and sine is positive, so that'll put us in quadrant 2 because our cosine is negative and our sine is positive. So what does that do for us? Well, we have f of x is equal to negative sine of 2x plus the square root of 3 of cosine of 2x is equal to 2, putting it in our format, 2, because that's our k value, sine of 2x plus phi. Well, what is phi? Well, if we think about the value of phi, what value or measurement do we get if we're looking at cosine being negative 1/2 and sine being square root of 3 over 2? What is our point there? Well, that would be 2 pi over 3. So phi is equal to 2 pi over 3 if we're looking at our unit circle. So this will get us 2 sine, I can factor out a 2 out of both of those, so 2 times x plus pi over 3. So if we were looking at graphing this, it would be a sine curve because it says it's sine. Our amplitude would be equal to 2. Our period would be equal to 2 pi over k. K is equal to 2, so we have 2 pi over 2, which will get us pi. And our horizontal shift would be equal to pi over 3. It'll be negative because it's opposite of what we see, and that means it's going to shift to the left. Okay, so we're looking to look at the graph. I'm not actually going to graph it. I'm going to show you the picture. If I can get it here on the book. So here is the picture of it in the book where you can see that it has shifted to the left, negative pi over 3, and you can see the sine curve happening right there. And that's on page 550 in your book if you want to look that up. All right, so thank you for coming to class. I appreciate that. Let me give you the homework assignment, and it's already posted online if you want to look it up there. Sorry about that showing up. I hope it doesn't show up in the videos. Computers, what you gonna do? All righty, so this was 7.2. So your homework is going to be 3 through 6, 9 through 12, 15 through 18, 21, 22, 25, 26, 33, 34, 55, 56, 59, 60, and 63. Let me scoot that up a little bit. All right, so do your best to do what you can. It should be due on Monday, but I understand that sometimes it's a little crazy. So if you want to push it to Wednesday, but you need to work on this, remember what's due on Monday. You have all your homework from the last test is due. If you turn it in past Monday, you're going to lose 25 points off of each homework assignment. So get done what you can and turn in. If you guys have an 8 o'clock class, so I will give you till the time I leave on Monday to get that turned in. So if you work on it and then you get stuck on a couple of problems and want to get some tutoring on Monday, you may do so, but you need to get it to me. I usually give the paper grader the papers around 3:30, so make sure that you are showing up for that. Before then, get me the homework so I can get it to him so you don't lose any more, you don't lose your points at all. But you need to get that turned in. You've got to take this seriously. That's all of 6-2, 6-3, 6-4, 6-5, 6-6, 5-3, and 5-4. Those are all definitely due Monday, and then they're going to lose points. You also, this week we covered 7-1 and 7-2. 7-1 you should be able to turn in But if you want to hold off on that, if you're getting caught up on the other ones, I'll let you do a little bit of that. But you need to get me that stuff then by Wednesday. All right? Have a great weekend. Thank you for coming to class. Make sure you got credit for your attendance today, and I will see you on Monday. Thank you.